Okay, cool. Got it going. We're up and moving. I think I've got most of my stuff at least in a semi-functional place over here. Let's start looking at this bell work. So expanding is what we did on Friday. And that's when we're taking things and we're trying to make this have as many logs as possible. So what do we need to do over here? What's our first instinct on this guy? Don't say cry.
You put the log base of 5 with each of, I guess you could call them arguments?
We're going to break them up into separate arguments, right? Yeah. They're the terms in the argument, but I totally get what you're saying. Totally get it. So we're going to split it up into its separate pieces. This is a 3 times x to the 4th times y to the squared. And every place we have a multiplication, we split that apart, and multiplication becomes addition. So we're going to have our log base 5 of 3. I'm going to just switch this to be purple. There we go. And so we're going to have our log base 5 of 3 plus, we get a new log now that we put a plus in. Log base 5 of x to the 4th. Putting a plus in, so we're going to get a new log of y squared. Every time we had a multiplication, we're going to turn it into an addition. One more step on this one. Because we didn't have any divisions, we couldn't make division become subtraction. We already did our multiplication becomes addition. Last piece. Our exponents, what are they going to do? Say it again because I didn't hear you. They go in front. They come down and go in front. This guy comes down and goes in front. They're going to become coefficients. They're going to become multipliers. They come down and go in front. However the words work for your brain, think of it that way. So our answer on this is going to be our log base 5 of 3 and our 4 log base 5 of x and 2 log base 5 of y. I don't have a 5 on here because I forgot it. And each one of these logs has just one thing in the argument. That's how we know we're done. If there is just one thing in the argument, it is fully expanded and there is not more that we can do. So that's how we know we're done expanding. Yes, dear.
Why didn't the 3 go in?
Because the 3 is not a power. If it was a power, so if this was something to the 3rd, then it would go in front. This is just a number. Good question, though. Good question. All right, this one's a little tricky, but we can do it. If we are asked to find the inverse, what does that mean we do? How do we find the inverse of something? Change the y for x and the x for y. So we're going to come in. We're going to find our letter x. We're going to find our letter y. We are going to make them change places. So to make the inverse, we make this be x equals 5 to the y plus 2. But we don't like to have x equals. We'd much rather have y equals. So what can I do to try and get my y by itself? We can't do the square. If it was squared, we could do the square root.
-2.
Let's start with getting the 2 away so we can get this piece by itself here. So we're going to make this be x minus 2 equals 5 to the y. And I'm going to put a set of parentheses around this side. How do I get something out of a power? Can't take the square root, only if it's to the power of 2. can we do a square root?
Log.
Switch it into log form. I want the power to be in the regular line of numbers, so I want the power to be down in this kind of regular line of numbers. So we're going to switch this into log form. My base, let's switch it into a darker blue. There we go. My base is the 5. My power is the y. And my x minus 2 is our argument. So if I switch this into log form, we're going to have our log base of 5 to the or of the argument x minus 2 equals our power, which was y. So 5 to the y's inverse is log base 5. We hadn't put it together in those words so much, so I wanted to go through that one with you. This is our inverse. Exponential functions and logs are inverse functions of each other. Okay. Questions on that bit? Ow, my back is screaming at me today. Okay, so we are going to be in your packets again today. Oh, snap, we are shocked. What's up? Yeah, give me a second. We are going to be on page 7 because we took on Friday some chaotic logs and we stretched them out to make them longer like this. What we're going to do today is I'm going to give you really long ones and we are going to squish them back together into a single log. Yeah. I was like, I don't try and make things up in my head as we go. That's not a wise prospect for me. So, we're going to be looking at our properties again. So, if you do not have these written down, they were on the previous page. If you do not have these written down, here they are typed all up. Just using x's and y's instead of m and n. But they are literally the same thing that we wrote on Friday. So if you do not have these from Friday, copy these down. This is our product property, our quotient property, and our power property. They are 100% exactly what we wrote on Friday. On Friday, we just used letters M and N instead of X and Y. Literally the only difference. Boom shakalaka. Okay. So on Friday, we had our steps to expand, where we talked about how our division was going to become subtraction, our multiplication became addition, and our powers become coefficient. And when we're looking to condense, when we're looking to make things smaller, we're just going to work it in the opposite direction. So our steps to condense, to make it smaller, our very first step is going to be to take any coefficients become powers. Helps if I spell that right. So our step 1 is that our coefficients become powers. Then we're going to do that addition becomes multiplication. And then lastly, since we ended with subtraction, or began with subtraction last time, we're going to start with subtraction this time. Other way around. I'm good at words. Subtraction becomes division. And for the how we know we are done, we should end up with only one log. Every single one of those, when I take addition and make it multiplication, we lose a log. So we are done when there is only one log. So we know we're done when there's only one log. So our coefficients becoming powers doesn't affect the number of logs we have, but the addition changes how many logs we have, and the subtraction changes how many logs we have. So we're going to practice this with the ones we've got down below. Okay. So let's look at a couple of them. So here's 1 and 2 from down below. So we've got, for number 1, we're going to start by looking at our coefficients. Our first step is that our coefficients become powers. So I'm going to come in here and I'm going to find any place we have a coefficient. So I've got this 2 out in front. It's going to go up and become a power on the x. This 7 out in front is going to go up and become a power on the y. So when I come to rewrite this for the first time, we're going to have log, same base as the one we had above, so it's just going to be that common log, so base 10 of x squared plus our log of y to the 7th. So the coefficients, the numbers in front, go up and become powers. Then our next step, we are going to do our addition becomes multiplication. So now we have a piece that's going to change how many logs we have. Our addition is going to become multiplication. That means I need to multiply this piece with this piece. So when we write this, condense down, thank you, sir. This is going to become log of our x squared times our y to the 7th. So the addition becomes multiplication. You don't have to necessarily put the dot in between. You can. I think it's helpful to have a visual, but you don't have to. You could just write that as log x squared y to the 7th. And since we've got this down to only one log, we are done. That is fully condensed. So this is our final answer. We're looking to get this down to be just one log with no numbers in front, nothing else wild happening, but just one log. Questions on that first one? Okay, same vibe on the second one. We've got ln's in this case. ln just means log base e, so it's still the same thing. So we start with taking our coefficients, and they become powers. So my 6 is going to go up over the z. The 4 is going to go up over the x. And the 5 is going to go up on the w. So my first step in rewriting this is we're going to have ln, sorry, I'm going to do that separately, ln of z to the 6th plus our ln of x to the 4th plus our ln of w to the fifth. Our coefficients become powers. Then this one doesn't have any other things than addition. So we're going to take our addition, means we multiply these two arguments. Addition means we multiply with this argument. So all three pieces are going to get multiplied together. So we're going to write this as ln of our z to the sixth times x to the fourth times w to the fifth. The whole point is to get rid of logs. We want to have fewer logs. The whole point is trying to make this thing have less logs, because we look at them and go, ew, too many logs. Ew. Thank you. Okay. That one you keep. All right. Questions on these two? Okay. This one has a very, very tricky bit on it, but it's not super tricky at the beginning. So here's number 5. We're going to start by taking our coefficients and making them powers. I do have one coefficient in here that we're going to use. We've got this 2. Our coefficient needs to go up and become a power. So I'm going to start by rewriting this as our log base 7 of 3 and our minus log base 7 of 4 and our log base 7 of 5. Our next step is supposed to be that our addition becomes multiplication, but I want us to pay really close attention. Which things are positive, like our log base 7 of 3 and our log base 7 of 5. These guys are both positive, right? Yes, sir. Oh, power. I got distracted. 2. Thank you. So those pieces are both positive. What I mean by that is they're like positive log base 7 of 3 plus log base 7 of 5. And we have that minus log base 7 of 4 squared. This guy is going to wind up being our subtraction becomes division. But these two pieces are positive. I try and make it so we don't have this, but I didn't honestly write the packet. So if it helps, I'm going to rewrite it with these two pieces next to each other, because these are the two things that are going to become multiplied with the addition. These are the guys being added together. This guy's being subtracted. So it shouldn't really come up many more times. I usually try to make things fix better than this. But, you know, I didn't write it. So if I rewrite this, because it doesn't matter what order we add or subtract things in, I can put this as putting our plus our positive pieces together. Yeah, give me just 1 second. Let me finish the line. Log base 7 of 4 squared. I didn't technically change our equation. I just moved it around a little bit. But that's going to let me put my two positive pieces together using the fact that our addition becomes multiplication, because I don't want to put a minus into the middle and I don't want to subtract something that I'm not supposed to subtract. So we got to watch out. We got to be super duper careful and make sure that we are switching our addition between things that are being actually added together, not including it into a subtraction. So our next up on the rewrite is going to switch this to become our log base 7 of 3 times 5 minus our log base 7 of 4 squared. Really don't like this one being step number 2. Because our next step on this is to take our subtraction and make it become division. This is my numerator, this is my denominator. I'm going to go this way just because I'm running out of space. So this is going to give us a log base 7 of a fraction that has 3 times 5 in the numerator and 4 squared in the denominator. We just need to be really, really careful that the only thing we subtract, or the only thing we divide by, is the negative up here. So the only thing that's being subtracted. That guy's my denominator. So just be really, really careful. Again, it shouldn't come up super often. It's much more likely to look like number 6 when we have a weird subtraction than it is to look like this. Look at the homework and see if we got any that are weird like that. Yeah, on the homework, there's not any that go weird like this. You can just follow our order like normal. This one just gets a little weird, and I don't like it, but it was already printed, so we're rocking with it. Let's look at number 6. It's much more logical. Feels a little bit more normal. All right, so our number 6 here, we're going to follow the same steps. Coefficients become powers, then addition becomes multiplication, then subtraction becomes division. So our first thing is our coefficient becomes powers. So what pieces are we going to move first? The 2. I've got a 2 here, and I've got a 2 here. Both of those are coefficients. They're going to go up and become powers. So our first step on this rewrite, condensing this down, our first guy's not changing at all, our log base 5 of x. Then we're going to have a plus, and our log base 5 of y squared minus, and then we have this parentheses. We can do that. It's just grouping together. Our log base 5 of x squared plus our log base 5 of y. So we took our coefficients up and made them powers. Now we need to take anything we have that is addition and make it multiplication. So I've got a plus over here, which means I need to multiply those 2 arguments together. And inside my parentheses, we also have a plus. So I need to take this piece and multiply it with this piece. What's up? Oh, yeah, give me a second. Okay, so we need to take and set up 2 different pieces like this. So we're going to have our log base 5 of x times y squared. That's our first piece. And then we're subtracting the combined together log base 5 of x squared y. Since we combined it together, it makes it just one piece, and I don't need to have those parentheses anymore. Yep, we still got to do the subtract. I'm just getting us to that part right there. There we go, dear. All right. Yep, one last step is now we have subtraction that's going to become division. I'm going to switch that out for a highlight. Subtraction is going to become division. So we can write this as our log base 5 of the fraction that has, this is my numerator, so my x y squared, and this is my denominator, x squared y. On this one and on the previous one, we could simplify these a little bit. I could look at this and try and simplify it. On the last one, I could take those numbers and I could multiply them out. I'm also okay with us leaving them unsimplified for now. Okay. Questions on this one? There's 4 more questions left on the page to practice our expanding and our condensing. And I want you guys to try those. There's 4 left on the page. See what you can do with that. Give them a shot. I'm going to walk around and see if we can work through some together. But I want you to try those. And in fact, I'm going to go ahead and set up a thing. I don't know if I can. See if you can expand out these ones. So this is doing what we did Friday and in the bow work. See if we can expand these ones out. And while I do that, I'm going to pass back a little bit of stuff. And then I'll work through this one. So I want you to try these 2. I'll pass some stuff. I'm going to do the same thing on the last 2. I think I have for you guys. So what do we get as our expanded form for this first one, for number 1 here? The fully done one.
Log base of 4, 16 plus log base of 4x
Yep.
plus 3
Yes.
log base of 4z.
Gorgeous. Perfection. Every place that we had, not the line like that, multiplication became addition. And our 1 power that we had became a coefficient in front of it. So it's using those pieces in the very, very same way. Number 2 is very similar vibe. How many logs do we wind up with for number 2? 4. We should wind up with 4 logs. Because the 3 is going to get a log, the x is going to get a log, the 2 is going to get a log, The whole y squared is going to get a log. Everybody is going to get a log. And we can either have it with parentheses, like that last one that we had, or you can do like a distribute the parentheses kind of situation, but not super concerned. Parentheses is probably the easiest of options. So it should wind up being, I can put it down here, our log, and we don't have a base, so it's our common log. So our base is what? 10. So our log of 3 plus our log of x, that's our numerator on our fraction. And then our denominator, so the thing we've subtracted, I'm going to set my denominator in these parentheses. We're going to have our log of 2 and our 2 log of y.
Are you gonna do the same thing with 3 and 4?
3 and 4, same vibe.
Miss me,
Yes, dear.
are you putting it, oh, because you have to put the 2 on because you change when we put the coefficients for that.
Yeah, so this is just at the very, very, very end. So working this, I would do this in a couple of steps to do our subtraction, then our multiplication, then our power. I'm just getting to that end. So yeah, because this had a power, it became a coefficient on the y piece. But I was just trying to get it so that, trying to make it so it's not just me doing everything out loud and y'all staring blankly at me like zombies. Because it's getting a little zombie glare-ish in here. So I'm trying to make it less me talking, but there's still a lot of me talking. Naturally, because we need to listen to me. Mwahaha. Okay, try the last two. 3 and 4, we're going to condense these down. Get all the way down to 1 log. These are the last two for today. How's that? And then I'm not even giving you no homework assignment. We love that. I know we got homework on Friday. But I want us to try this. And then we should be ready to rock and roll and go for that homework. I want you to try and get these all the way down just to 1 individual log. 1 log left. It's the last log standing. Oh my gosh, I got so many emails. What the heck is this? Okay. So for number 3, when we get it down, we should get down to 1 single log base 9. Number 4, we should get down to 1 single log base 2. Ow, that was a big static shock.
I could, for some reason, on Saturday, I kept shocking my one.
Oh, it's because it's very, very dry out, and this building just builds static electricity like nobody's business. I get zapped in here on a very regular basis, particularly from these. If you notice when I walk past, almost every time I reach out and tap it as I walk past, trying to ground out. I have gotten zapped so many times by those dang filing cabinets. All right, what do we get as our argument for number 3? Because we have a minus sign, so we know we're going to have a fraction. What's our numerator? So the denominator is going to be the x. Yeah, our denominator is going to be the x, absolutely. What's our numerator? What's the top? Y squared and z to the 4th. 100% perfection. For number 4, we're going to get this all the way down to log base 2. Again, we have a minus sign in here, so we know we're going to wind up with a fraction. What's my numerator? The top. Yeah, the numerator is going to be the 50. And our denominator? What's in the bottom?
5 squared. And then I put 3 squared in parentheses because of my sanity.
Totally fine. You can do 5 squared times 3 squared. We can do 5 squared times 3 squared this way. You can do 5 squared times 3 squared this way. I could go, wait a second, 5 squared I know is 25. 3 squared I know is 9. And we could multiply it out. Absolutely valid. But I'm also totally okay with us leaving it right here. Okay? End of day. Happy Monday. We've made it through. I'm going to get our announcements up.